Why? Are you getting confused? And are you getting scared about the numerical, especially networking numerical? And the sliding window numerical, where you have to do the propagation delay, maximum efficiency, what will be the minimum bit, what can be the achievable throughput, totally confused how to do it. That's why this video is for you, and here I am going to tell you in detail from beginners, means I will think like that you are totally beginners here, and that's why I will explain the concept. After that we will solve this question. Here you can see all this question I am going to discuss here. For this question, 5 question was there. It is actually I took this question from UGC NET 2022. Yes, this question asked on UGC NET 2022. But if you are preparing for any exam, then this question will be definitely helpful to you. So that's why definitely watch the video till the end. Please don't stop in the middle. I saw that it is a habit of some students. They are watching 4 to 5 minutes. After that they are going to stop. Don't stop it. Complete video. If you watch the complete video, after that definitely your all concept will be clear, and you will be there will be no scared, no fear. Why? Priyanka ma'am is here. So let's start. Here you can see, before coming to the question, I want to show you some concept that is more required. So that's why I am taking some slides, and let me go to slideshow and let me discuss that concept. This is actually the flow control protocol. In the flow control protocol, there are stop and wait protocol. First of all, there was the stop and wait protocol, and another part is there. These are flow control protocol, and another side is there. This is the sliding window protocol. So how this is working? Main concept, if you know, then only you can relate it. Flow means what? In network some flow is going on. What flow is going on? Actually from sender, here is the sender. Sender is sending some packet to the receiver, right? So whenever sender is sending the packet, it is not a small packet. There are so many parts are there, and it have to load into the channel, means through where it will be like that. It is a track. So the track is loading. Track have to be loaded. After that, track will start the transport, right? So here the concept is coming of transportation time, means actually the TT. TT means transportation, not it is transmission time. So here what is transmission time? This is actually the transmission time. What is that? To load it. How much time it is taking to load the data, that is called the transmission time. Means actually you are loading the data into the channel. This is called transmission time. Now what is propagation time? When you are sending it to sender to receiver, this is called the propagation time. To transfer one bit of data to the receiver, how much time it will take, that is called the TP, means propagation time. This is the first concept you need. Now, how to calculate it? What is the formula for transmission time and propagation time? So transmission time and propagation time is that when we are doing transmission time, that is TT. TT means what it will be? You are loading the total data, right? Means what will be the total data size divided by bandwidth. Bandwidth is the capacity of your network. Whenever you are in mobile also, it is showing that bandwidth 100 kbps, 90 kbps, means what? That is per second time how much data I can load, or how much data I can show, how much data I can download. That is actually your speed. So that's why transmission time means length of your packet divided by bandwidth. Length by bandwidth, that is transmission time. Now propagation time, TP. What is propagation time? Propagation time is depending on the, it is length of the packet. Okay, it is not length of your means your sender to receiver. It is the length or the size. You can write down that here also, length or the size of the packet. TP means it is the distance between sender to receiver, because ultimately I am sending the data to sender to receiver. That's why here the total distance, that is here. So this is the distance between sender to receiver, divide by what? Transmission speed. Here it is bandwidth. Okay, bandwidth is different, transmission speed is different. It is bandwidth. Bandwidth means it is actually whatever bandwidth you have. Speed means in how much speed actually working. So this is transmission speed. These are the two main formula. It is not only for sliding window protocol, for networking numerical always you need this. What is transmission time? What is propagation time? That is the first thing. Now come to this protocol. What was the stop and wait protocol? Stop and wait protocol is like that. Sender is sending some data. Here is the sender. Here is receiver. And sender is waiting for that time when receiver will send the acknowledgement to the data. Means it is the data it is sending, and whenever receiver will send the acknowledgement, after that only it will send another data. So you can see here is a wastage of time. This time is actually wastage. So how much time actually it will take to send the data? First of all, to send the data, it have to load, means transmission time, plus it have to send the data, means for sending it needs a propagation time, that is a TP time, and to send the acknowledgement also it's need a TP amount of time. So means it is actually taking TT plus 2 TP amount of time. Now come to the efficiency. What is called efficiency? Understand that also. What is efficiency? Efficiency we are writing like this way. Efficiency means, what is our efficiency? Efficiency means it is the useful work, means whatever actual work you are doing by the total work. Like that, if you are watching my video for 20 minutes, within 20 minutes actually how much you are concentrating and actually how much you are learning. Another time you are looking it but your mind is not there. Your body is here but your mind is moving any other work. So that is useful work by total work. So always ask yourself, are you watching this with a full of concentration or not? Otherwise ultimately your efficiency will be 0. So whatever time you are investing, actually whatever work you are doing, I am learning for 2 hours, but after 2 hours, how much is my output? That is your efficiency. So that's why, see here, actually how much time? Here is a wastage. This 2 TP amount of time is wastage here. Sliding window is trying to, because here this time is waiting. This time, this 2 TP amount of time, the network is waiting. That time sliding window is coming to a smart idea that okay, why I will wait for that time. In this time, when I am sending one part of the one packet, then this packet will go, after that I will receive, and this time is exactly 2 TP amount of time. At that time, if I send more data, if I am sending more data, then actually I can utilize this and my efficiency will improve. That is the concept behind the sliding window. Sliding window can send, here sliding window there are two types actually, the go back in and stop and wait. Stop and wait, not sorry, selective repeat. Selective repeat. Okay. So go back when, how it is working? Go back in is working like that. N number of packet it can send at a time. And this N is depending on this 2TP. This N is depending on this 2TP, means in this amount of time, how much data I can transmit, that will be in this time. Right? How it is I am telling. And receiver side, it is the receiver side. Receiver side can receive only one packet at a time. That is the main thing here. Now, how to calculate it? See that. If I am telling my TP is 1.5 millisecond. So, what will be my 2TP? 2TP equals to 3 millisecond. Right? Now, if I am telling that transmission time is 1 millisecond. So, actually to load this much data, I need 1 millisecond. Now, extra time was 3 millisecond. So, in this extra time, how much data I can transmit? Definitely, in this extra time 3 by 1, that is 3 more packet I can send. So that's why what will be my window size? Already 1 data plus this 3 data. So 1 plus 3 means 4. My window size, that is N, will be 4. That's why window size is coming 1 plus 2A. It is depending on this. A is what? A is TT by 2TP, that is A. That is A. TT by TP is A. Okay. So now come to here. Now we will discuss the concept. Actual concept is here. Now go to this numerical. Otherwise you will think that okay, ma'am is not explaining numerical. So go to the numerical. Basic concept we did it. Now try to solve. Pause the video and try to solve it, because I already told you the transmission time and propagation time how to calculate. Read the question and pause that. You already know transmission time how to calculate, propagation time how to calculate, what was the formula, recall it and do it. A 300 kilometer long trunk operates at 1.536 mbps and is used to transmit 64 byte frame and uses sliding window protocol. The propagation speed is 6 microsecond per kilometer. Then what will be the transmission and propagation delay? I will suggest please pause the video, try to do it, and after that let me know in the comment section, are you able to do it or not. Now I am showing you what to do. Just now I told you that propagation is what? Propagation speed, this is given, distance is given, this one, these are your given data. Right? Now what to do for transmission delay? Packet size by bandwidth. So packet size is what? 64 byte. Bandwidth is what? 1.536 mbps. Now here is a big problem. It is 64 byte guys, and this is 1.536 mbps. Now always remember, whenever you are doing mathematics, then you need to convert in same unit. mbps means megabit per second. Small b means that is bit, capital B means it is byte. And that's why I am going to tell you something, that is 1 byte means 8 bit. Remember. And 1 KB means kilobyte means 2 to the power 10. You have to multiply with 2 to the power 10 to convert it in byte. In byte it is 2 to the power 10 byte. Okay. Next one, 1 MB means 2 to the power 20 byte. 1 GB. 1 GB means 2 to the power 30 and 1 TB means 2 to the power 40. This units conversion is very important and it is byte. Whenever it is byte you need to convert in bit. After that you have to do it. And microsecond, millisecond, if this is millisecond, that is 10 to the power minus 3 second. You need to convert in second. Millisecond. If it is microsecond, that is 10 to the power minus 6 second. If it is nanosecond, that is 10 to the power minus 9 second. Okay. These conversion are very important. And now mbps, kbps, gbps, these are the data in speed or bandwidth is given in mbps, kbps, gbps. kbps, when you have to convert in bit per second, means you need to multiply with 10 to the power 3. It is 2 to the power 10 and this is 10 to the power 3. Don't mix up. These are the size of the file. When you are working on size of the file, that is KB, MB, GB, TB, that will be multiplied by 2 to the power. And whenever you are working with speed, bandwidth, that is kbps, mbps, gbps, then you have to multiply with 10 to the power. kbps, if it is mbps, then it will be multiplied with 10 to the power 6. gbps is multiplied with 10 to the power 9. These are very important. Must remember, otherwise you will do mistake always. And that's why these unit conversion students are not doing, and here are the problem. Now come to here. Now so that this byte I have to convert in bit. So I told you 1 byte is 8 bit. So 64 multiply into 8. Now this is converted into bit. mbps I have to convert in bit per second. That's why I have to multiply with 10 to the power 6. Now this is both are, it is in bps, bit per second, and upper is bit. Now you can do the operation. Now it is perfect. And now if you are calculating, after calculation you will get 333.33 microsecond. This will be coming in microsecond because propagation delay, it was question was asking in microsecond and we have converted it. Means actually it is converted in second. Your answer will be come in second. After that, as option is asking in microsecond, that's why we are converting in microsecond, because our option is given in microsecond. Here your answer will be come in second. Okay, whenever you are doing this operation, this will be in second. Now second you have to convert in microsecond. How to convert in microsecond? Because already I told you that microsecond means that is 10 to the power minus 6 second. Okay, so you will get the answer and it will be divide by 10 to the power 6 means 10 to the power minus 6. That's why we can say this is 333.33 microsecond. Now see that. Now we will go to the next question. I hope it is clear to you how to do it. Next question is, so your answer will be okay. Another part was coming, another question was that transmission and the propagation delay. So we did here the transmission. Now what will be the propagation delay? Propagation delay already given here. That propagation speed is given here actually. Propagation delay did not given. Propagation speed is 6 microsecond. So what will be the delay? How much delay? Because distance, it is depending on distance. Delay means what? How much distance you are covering. That distance multiply into speed. That is delay. So distance is multiplied with speed. So your delay will be 18,000 microsecond. That is propagation delay. Okay, be careful. Next one. Now this question is asking you the sender window size to get the maximum efficiency. What should be the sender window size? I told you what was the concept of sender window size. That is, I will send some data. After that 2p time, extra time I am waiting, I have to utilize that time. How to utilize? That is depending on TT, that transmission time, actually how much needed, and in this 2 TP time how much data I can send. And that was, what was the formula? Yes. I hope you can recall. Pause the video and do it. Yes. I hope you did it. Now come to the answer. So answer was 1 plus 2a. That was the formula for window size. And what is a? A is TP by TT. That we did there, right? In that time what we can do? Means 2 multiply into 1.5 divide by TT I calculate, right? That was the 3 by TT. 1 means that's why it was 3 and 1 was extra. That's why we got that 4. That concept is coming here. So TP by TT, A is this. Now put that TP is, but just now we calculate that TP. TP was propagation delay. It is not the propagation speed. In question it is given propagation speed. Don't do that mistake. Last question only we did the propagation delay. That was 18,000 microsecond. So 18,000 microsecond, 18,000 microsecond divide by 333.33 microsecond, that is the TT. You will get here 54. A is 54. So 1 plus 2a, whenever you are doing, your answer will be 109. And that is your optimal window size. How to calculate optimal window size? Why this is coming? I hope it is clear. Now remember that. Okay. And don't do mistake A equals to TT by TP. Please no. It is TP by TT, because ultimately we are checking how much time is wasting. Now in that time how much I can transfer. That is TP by TT. Next one. Now the next question is the minimum number of bit required in the sequence number field of this packet. Now what is the minimum number of bit required? This is the concept I am going to tell you, and after that it will be easy for you. See that minimum number of bit. What is the funda? What is the concept of bit? Bit concept is that, see, if I am sending maybe I am sending 8 packet. Okay, so I can send 8 packet. Now it is 8 packet means decimal system we will say 1 2 3 4 5 6 7 8. But this is working in binary. Computer science is always working in binary. So I have to represent in binary, and binary is always working starting with 0. So 8 packet means 0 to 0, 1, 2, 3, 4 till 7. These are your 8 packets. In binary, how to represent? Binary representation of 7. 7 means to represent 7 I need 3 bit actually. 1, 1, 1. That is the binary representation of 7. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 and so on. You have to think about the last number. To represent that last number, how many bits are required? For 8 packet, last number is 7. To represent that, I need how many bit? 3 bit. Right? How it is coming? This is actually 8 means 2 to the power 3. That is this 3 bit. This is the 3 bit. If I am telling you I can transfer 32 bit, then 32 packet, then how many bits are required? 2 to the power 5, that is 5 bits are required. If I can say 1000 packet, then how many bits are required? See that. You have to take a nearby value, that is the upper bound, what can be converted in 2 to the power. So 1024 can be converted in 2 to the power, and that is 2 to the power 10. So how many bits are required? 10 bits are required. So now you tell me that what was my packet? How many packet we can send? Just now we did it in the last question. And from here Now you can understand what will be the bit required, how many bits required for the sequence number. Tell me, you can do it. Pause the video, do it, and after that tell me in the comment section. Yes, the answer will be here definitely, as just now we did optimal window size is 109. Means I am able to send 109. My sequence number is 109. So to represent 109, my near about value, I have to take the near about value, right? 2 to the power 6 is 64. It's not possible. 2 to the power 7 is 128. So nearby value means if I am taking 7, then I can represent 128 number. It is 109. So I have to take 7 bit. And that will be my answer. Clear? Yes. Next one is this one. So this is asking you if only 6 bit are reserved. I saw that for my optimal window size I need 7 bit. But I am not able to give you, means I have only 6 bit only. More than that I cannot allocate. If I am allocating you 6 bit for the sequence number, then what will be your efficiency? If I am allocating you 6 bit, then what will be your efficiency? For 100% efficiency, optimal window size, we did it. Now it is if I am giving 6 bit, then what will be my efficiency? Efficiency was actual work by total work. Right? Yes. Here the answer will be efficiency is sender window size divided by optimal window size. Means actually what I am giving. That is 2 to the power 6 I am allocating you. Means 6 bit means if I am allocating you 6 bit. What is the size? 2 to the power 6. And originally 7 bit was there, means what is the size? 2 to the power 7. So that's why 2 to the power 6 by 2 to the power 7, 64 by 109. Your answer will be 0.587. That will be the efficiency if I am allocating here 6 bit. Now next question. Next question is maximum achievable throughput. What can be maximum achievable throughput? Do it. Yes. Here throughput means actually efficiency multiply into bandwidth. Throughput means actually work, how much work you are doing. With your efficiency, whatever bandwidth is, efficiency multiply into bandwidth, that is called throughput. So efficiency is sender window size divided by optimal window size, that was your efficiency. Now with that efficiency, if I am doing bandwidth, what is my bandwidth? Bandwidth is 1.536 and my achievable throughput will be 0.901. That is my achievable throughput. So I hope these all are clear to you, and 901 is the last answer. This is 0.901. Let me know in the comment section if it is clear to you or not, and what you think and how I can help you. And stay tuned with this channel. Please share this link to your parents also. They will also get the benefit. And try to attempt the mock test that I am pasting, that I am creating the mock test in the community section. Please attempt it. Today also I have posted that, but you did not attempt. So very less number of learners attempt that mock test. Whenever you are attempting mock test, then only your performance will improve. Okay, so try to attempt mock test regularly and always watch the video regularly, so that your learning will be complete. Thank you. Stay tuned with this channel. Bye bye. See you soon in my next video.